Okay, I wanted to talk to you about the melatonin receptor right now. And this is an interesting topic because most of the time the melatonin receptor will be present in the cellular membrane, even if melatonin is more fat soluble, okay? But it can also be present in the nucleus. So as you can see, this is the reason why you need to learn a little bit more about the single hormones because the rules are useful up to a certain extent. Okay, now let's try to understand a bit more this context here. And I really want you to see the way I see things when I do this kind of research because in the disease you will specialize in, be it Hashimoto's or whatever, you're not going to have millions of hormones to be involved. They're going to be maybe like three, four, and they're like receptors. So when you do this kind of work, then you're really, really ready. Like you are ready to an extent which is much superior than the other therapists. This is why you have to do all of this kind of stuff. All right, let's have a look here. So melatonin has specifically two receptors, MT1 and MT2. In most cases, these receptors here, as you will see here, are in the cellular membrane and they activate essentially a second messenger called C-AMP for them to function. These same receptors may also be present in the nucleus, especially of neurons. So yes, this is the way you normally will find them. But since melatonin can also cross the blood-brain barrier easily, you can also find them inside of the cell. This is an important part. If you remember, like I think I did show you melatonin here. Like as you can see, this is something that basically can go anywhere. Okay, so let me go back to what we were discussing here. Now, both of them are receptors that belong to the class of rhodopsin-like enzymes. And this is an important point, which I will now look online and find it for you so you can explain something. Okay, let me see if I'm recording. Yes, I am. All right, so they are called rhodopsin-like receptors. Now, do you remember what rhodopsin is? Think about that. You probably have heard of it. You have heard of it when you were studying like how to see, how the eyes can see. Okay. And rhodopsin is essentially like a pigment, like a protein, which acts like a pigment that is essential for our sight. So what does it mean for us? It means that melatonin, like the melatonin receptors, they really respond on top of other things that we're going to see later, but also to light. And that's a very important point. And this will be something extremely important that we will see in the case study that I will present at the end of the course. Okay. But I think this is something that's becoming fairly like well known in the world of medicine right now. And it works like this. So first thing in the morning, when there is the possibility of having light, otherwise you can use like a lamp, like a let's say like white light lamp, which I'm gonna give you an example in the case study. But one of the few things to do, like first thing in the morning, would be to be able to look at the sky, not at the sun, obviously, or it's gonna burn your eyes, but look at the sun, look at the sky, sorry, look at the sky. And this is going to really have an impact on your melatonin. Like in the morning, it's basically going to release the melatonin from these receptors. Whereas at nighttime, it's the other way around. At nighttime, you want as much darkness as you can because that darkness will actually do the opposite. It will actually help you to bind more melatonin. Okay, it's an important point to remember. So light is really important, and you have to understand that because the receptors are rhodopsin-like, and just the word rhodopsin-like must make you think this is about light, right? And that's exactly the way it is. Now, as you can see, these are all in all of the basically like central nervous system, so very easy to find. They are present also in other cells. They have an impact also on blood glucose regulations, but largely this is the main part where they're useful, okay, in the central nervous system. Now, just to give you an idea, again, this is for a person who sleeps at night and doesn't have particular issues. So as the night progresses, the light should start, like, this is probably more during like maybe spring or autumn, not certainly summer, at least not here in Italy, where like until 9:30 there is no, like, there is still light. But you start to produce, as the sun starts to go down, you start to produce more melatonin, which is going to go up, have a peak, and then will start to go down. When it goes down, when most of the melatonin is leaving the receptors, you will start to wake up. That doesn't mean all melatonin has left the receptor. If you want all melatonin to leave the receptors, just look at light, okay? And it could be like let me show you now before. There's gonna be in the case study, but like largely you can just do like something like this, and like you can do like light therapy, and you can find something like this, which is, see, it's very bright. It mimics a little bit the light of the sun. It's not exactly like the light of the sun, but just being exposed to this kind of light will help you to like unpack and unbind the melatonin from its receptors. So it's really good. And another thing that you should be that people do, but it's incorrect, is to use caffeine to unbind melatonin for its receptors. So you should always wait at least half an hour before consuming caffeine in the morning, because otherwise you teach your body, you teach your receptors that in order for you to release melatonin, you need caffeine, which is not true. You need light, okay, because that's how the receptor works. But you can, like, let's say you can like break the code by using caffeine, something that does happen. Okay, now what are the main amino acids that we find in hair? So we have serine, we have threonine, and we have tyrosine. These are the main three. And a very particular point to remember here is threonine is an essential amino acid, which means it needs to come from the diet. Okay, so it means that our job as therapists, nutrition professional, or like anyway health therapists, is to cover all of this, because threonine cannot be made by the body. Okay, so it's so important to remember. Now we understand that. We understand like a little bit more about the receptor. Now, please do your own research. Okay, do your own research on your own receptor, because this could be such a massive difference between what you do and what other people do. Okay, so I'm gonna stop here, and in the next part of the course, there's gonna be your second quiz. Once again, it's gonna be 5 questions. Look at the questions, answer the questions, and then scroll down a page and look at the answers. Okay, this is gonna really make everything super easy for you. So I will see you in the next video. Ciao, ciao.